I made my own router, and here it is. This Raspberry Pi right here. It's got a USB drive coming off of it because I had one laying around and not an SD card, so I'm using that as the boot drive. You'll see it only has one Ethernet port, and this is doable if you have a network switch that supports VLANs. I do, so we can do that. But if you don't, you're gonna want to get a network switch that supports VLANs, or just get like a USB to Ethernet adapter so you can have two ports. Blue cable up top on port 13 is my modem, and then the one below it, port 14, is my Pi. First thing you're going to want to do, open your web browser, go to openwrt.org. This is the bootable file we're going to download. Let's see, and we're going to go to downloads, going to table of hardware, and then we'll just control F, we'll just search for the Raspberry Pi, and I am on the Raspberry Pi 4B, and then we're going to click this download image right here, and we're just going to throw that somewhere on our computer. All right, now that you've downloaded it, what you're going to want to do is open some kind of imager tool. I'm just using the Raspberry Pi imager. We're going to choose OS, go to use custom, go to that file we downloaded, then you'll choose storage, and you'll hit right. And now if you're using a USB stick like I was, you're going to want to remount the USB, go to the boot partition, find cmdline.txt. You're going to open that, and then where it says root equals /dev/mmcblk0p2, we are just going to change that to SDA2, and then you're going to save that, eject the USB drive, and then we're fine to boot. Now don't do that if you're using an SD card. Okay, only do that if you're using a USB drive. Okay, now what you're going to want to do is go plug your Pi in, put the USB stick in it, make sure it boots, and then plug it into your switch, or plug one of the LAN ports on it if you have more than one port into your computer. And then if you're using a managed switch and just doing one Ethernet port like I am, what you'll want to do right now is open the configuration for your switch. And I did the IEE 802.1q VLAN. Not a clue what that means, but I did that because openwrt had an option for that type of VLAN, so I just did that, right? Okay, so now what you're gonna want to do is, I have my Pi plugged into 14, so I have it as a untagged egress packet in my main VLAN, and then I have the port on my modem as not a member. Then in VLAN 2 I have my modem as untagged, I have my router as tagged, and then in your PVID settings you're going to want to set the default VLAN tag for your modem to be whatever VLAN group that it's in. So in this case it's in VLAN group 2, so it can be untagged in the VLAN group 2. Because I don't have access to my modem, I can't configure it at all, so I can't set it to use VLAN, so we need to make it think this is a normal Ethernet port. But we can tag the Pi because it can move between VLANs, because we have control of it. We can configure it, and it has that ability, right? Okay, and that's how I set up my VLANs. Ignore port 24 over here. That's just for my wireless router. It's not needed. Okay, now for your router, I think the default is 192.168.1.1. I think that's the default, but mine has changed since then, so I just did that. You won't have a password yet. So first things that you're probably going to want to do is go to System, Administration, and set a password. After that, we're going to go to Interfaces, Devices. You're going to go Add New Device Configuration. If you're doing one port with a switch, you're going to want to do a VLAN 802.1.q. We're going to use our Ethernet as our main device, so for us we're going to do VLAN ID 2. Now MAC address, you'll probably want to set that to the MAC address of whatever router your ISP gave to you, because for me it doesn't work unless I do that. So just copy whatever MAC address is on your current router, put this here. Make sure IPv6 is enabled because we will need that later. If you're doing IPv6, And I believe that's it. And then you'll hit save. Okay, now in interfaces, you're gonna want to do is you're either gonna want to edit the WAN interface or add a new one. So I'll just do add a new one. We're just gonna name this WAN. It doesn't really matter. And then protocol, we want it to be a DHCP client. And then the device, we are going to do either the port plugged into your modem, or if you're doing VLANs like me, that VLAN that is in the modem's VLAN. You're going to click create interface. Then it should look something like this. You want to bring it up on boot. In advanced settings, you want to use the default gateway. I just leave that checked because I think it was default. And then don't worry about IPv6 on this interface because it can't get assigned IPv6. We'll do that later. Firewall, you want to put this in the WAN firewall zone and then just leave everything else default. Then you can save it. And if everything is working properly, you should be assigned a public IP address. I'm gonna blur mine for obvious reasons, but there you go. And then for IPv6, you're gonna want to make a new interface. We'll just call it WAN 6. And the protocol, we want this to be a DHCP v6 client. And the device, we want to use the VLAN that is hooked up to our modem or your WAN port, whatever port's plugged into the modem, if you have more than one port. Okay, and then it should pull up this. Now, you want to request IPv6 address. I just left that on try. Request prefix of link. I just did automatic. Then in advanced settings, we want use default gateway. Leave that default. Then we want to leave these unspecified. We want IPv6 source routing. That's on by default, so I just left it on. Then you want to delegate IPv6 prefixes. And you want to make sure assignment length is disabled. And firewall settings, set this in your WAN firewall zone, and there you go. And then you can hit save. Now, if everything works properly, you should get an IPv6 address assigned to you, and then you should get an IPv6 prefix delegate address. I'm going to blur these again for obvious reasons, but yeah. And then what you're going to want to do is you're going to want to add a new interface or edit it. If it already exists, you're going to want to do LAN. Protocol is going to be static address. Then device is going to be your non-VLAN Ethernet adapter, or just your LAN port if you have more than one port. Okay, then we're going to go in and edit this. And now this IPv4 address, I just set to 192.168.0.1 because I had other computers giving themselves static addresses, and that this just didn't conflict with my network. If you don't have any of that going on, you can set this to whatever you want it to be, as long as it's in the public space. So I think all of 192.168 is in public space, so you could do like .71.0 and that would be valid. Or you can just leave it whatever the default was. If you do change it to a different one, when you save and apply, it will give you a warning that your router is no longer accessible. You'll just want to force it to apply and then reconnect with whatever you assigned this to be. You can do whatever you want in here as long as it is a LAN address. And your IPv4 subnet mask, you just want this to be 255.255.255.0. Your IPv4 gateway, just leave this empty, it'll auto assign. I have to blur this for obvious reasons. And then IPv4 broadcast, just leave that default. Okay, now in advanced settings, you'll want to use default gateway. You want to leave that checked. You can put custom DNS servers in here. I just did the Google one. Then leave everything default. You don't want to delegate IPv6 prefixes on this because we're having our WAN interface do that. But we do want to assign IPv6 addresses through this interface. So I just set the assignment link to 64. Assignment hint, I left blank. Prefix filter, we want to set that to our WAN. The suffix preference, I just left that default. Firewall settings, you'll put this one in your LAN zone. Then DHCP server, you want to enable dynamic DHCP. Leave everything else default pretty much. Then for IPv6, your RA service, you're going to put this in server mode. DHCP v6 service, you're going to put this in server mode. I left this checked because I think that was default. Then NDP proxy, you're going to want to put in hybrid mode, and you'll want learn routes checked. Not entirely sure why or what any of this really does, but it worked for me. In the IPv6 RA settings, you're going to leave default router as automatic. you'll enable Slack, and then RA flags, I just have it none, and then you'll want to save that. Then you'll want to save and apply. You'll probably want to save and apply after you create each of your interfaces, because otherwise you won't be able to tell what's working, because you won't get assigned addresses until then. And if everything's working, you should have an IPv4 on your LAN. Looks something like a local IP, and then you should have an IPv6 prefix delegated to you. Now this IPv6 is public, so don't share that. What we're gonna want to do is we're gonna want to go to firewall. So make sure your LAN to WAN forwarding, everything is accept. Then your WAN, you want that to be allow forward to destination zones. You want this to be unspecified. Make sure nothing's clicked. Allow forwards from source. You want to allow it to forward from your LAN, and then you want your input rejected, you want output accepted, and you want forward rejected. And then I think masquerading, everything else is default. In covered networks, you want this to be both your WAN interfaces. And I think I just have everything else default in there. Now port forwarding works like it normally does. So if you want to make a Minecraft thing, go Minecraft, I think an external port 25565, internal address, you click what computer your Minecraft server's on, and internal port is 25565 like normal. Now if you want to forward, or I guess it's not forwarding because we're assigning public addresses, if you want to open a hole in the firewall so you can access an IPv6 publicly, you're going to want to go to traffic rules, and then you're going to want to add a new rule. We'll just do Minecraft, for example. Minecraft, leave it TCP and UDP. We want our source zone to be WAN. Our source address, leave that blank. Source port, leave that blank. Destination zone is LAN. Destination address, you'll click whatever computer your server's being hosted on, and your destination port will be 25565, and your action is to accept it. And that's how you open a hole in your firewall or public IPv6 addresses. Yeah, I believe everything else I left default, but you can do whatever it is you're gonna do. Yeah, good luck, have fun. Hopefully this was helpful. Thanks for watching. Subscribe if you want more content like this, and I will see you later.